Today we're going to look at real numbers, which are really any number that you pretty much can find an answer to on a calculator. And there's different categories of real numbers. The first category, or the most smallest one, is called the natural numbers. So we have our natural numbers, which are just your counting numbers. Then you have your whole numbers, which are those numbers plus 0 that come out without any fractions. Then we have our integers, which are decimals and fractions, but they also include wholes and naturals. And then we have our certain type of irrational, which are numbers like pi that do not come out with any kind of reasonable decimal. And then our last group is our rationals, which are those fractions that repeat or end. And so we have all different types of reals. So if we look at a number, we can classify that number based off of which category. So if we start with the negative 23, I know that it is a negative number, so it can't be whole or natural, so it must be an integer. But I also know that if it's an integer, it's also rational, because everything, if you look at the chart over here, every integer, z, is also underneath the umbrella of q, and q happens to be rationals. So anything in these circles, anything outside of it is also a member. So look at our square root of 50. If you put square root of 50 into your calculator, let me do that real quick. You get a decimal number that doesn't repeat. So basically, it's a decimal number, so it eliminates being natural or whole or integer. And since it doesn't repeat, it's irrational. And since there's nothing, if you look over here at irrationals, there's nothing in the irrationals, so that's the only category we have. All these are real, so you don't have to put reals down, but you do need to put the other subsets. So if we look then at our fraction, it's not natural and it's not whole, and it's not an integer. So the only thing it can be is a rational number. And that's our classifications of real numbers. So we have certain properties that are applied to these real numbers. We'll call the real number properties. And the first property is a commutative, which means when numbers change place or move. So basically we're talking about moving numbers. So if you take numbers that can be added or multiplied, you can change their order, and I'll write that in. Order will also work. So the order of the numbers changes. That's called commutative property. Now, if you group them with parentheses and you change what's in the group, but the order doesn't change. So if you look at this first problem right here, A plus B plus C, if you didn't look at the parentheses, and we look over here, A plus B plus C, they both are the same exact order, but the parentheses are on different letters. So that is called grouping or associating or associative property. So when you group numbers differently, that is the associative property. The identity property is pretty simple in that whatever you add, and you get the exact same number. So if you add 0, you get the exact same number. And we also have a identity property for multiplication. That means if I multiply by 1, I get the exact same number that I start with. So those are the identities because they repeat themselves depending on whether you're adding or multiplying. The inverse is when you actually get 0 when you're adding. So if I have a number, but I take its opposite, often called opposite or negative of it, then when you add them, I get 0. If you take and do multiplication, we're trying to get the number 1. So the inverse of A is really flipping it, or the reciprocal, so it's 1 over A, and when you multiply them, you get 1. The other property that's the most important one, and I'm going to star it, closure just means that all the numbers that we're going to deal with are in the real number system. That one's not as big of a deal, but the next one is. Distributive property is the most commonly used property in algebra because it combines addition and multiplication. And all it is taking parentheses, if you have something in the parentheses and something that's outside it, and distributing or multiplying it by the values that are inside. So what we want to do is do the math, but then name the property that we have. So the first one we have right here is we have 5 times 4 times 13, but the grouping changes. So since the grouping changes, but the order is the same, this is called the associative property. And you can abbreviate as long as you abbreviate appropriately. This is the associative property. Now, if we name this property, and we're taking, well, we have parentheses, and something inside the parentheses gets multiplied by each part, and we end up with no parentheses, that's called the distributive property. We want to find the additive and multiplication inverse of this number. That means we want to know if what I can add to this. So if I have a negative 8/5/8, what can I add to that so I get 0? That's the additive inverse. So the adding to that would just simply be the positive of that number. And so if we add that, so this is the additive inverse. Now if we look at the next one, the multiplication inverse, I want to know what can be multiplied to get 1. So what do I multiply it? Well, you just flip it, and you have to keep the sign, so I flip it. If you don't keep the sign, you won't get a positive number. And by flipping it, I can get 1. So this is called the multiplication inverse. Now, let's look over here at our 2.5. To do this problem, I'm going to make it into an improper fraction. So by doing that, I'm going to multiply the bottom times that's the number and add. So I'm going to get 5/2. So now we're going to do the same exact thing. What do I add to get 0? And let me change this. Let me do it in the consistent colors because, so our additive inverse, I have 5/2. I want to know what will add to that to give me 0. Well, it's just the opposite, so it's a negative 5/2. And then I want to know what will multiply. So we will do the multiplication. What will multiply to give me 1, which is just the flip. So the key is you have to change your mixed number into an improper fraction, because when I multiply this, I get 1. So there's our additive inverse and our multiplication inverse. So what we're going to do is simplify expressions, and all that means is we want to remove parentheses, and I'm just going to abbreviate with parenthesis signs. Remove parentheses, and we want to combine like terms. That's the definition of simplifying an expression. So let's look at this expression. And so if I remove the parentheses, I'm going to distribute. So 3 times 2 is 6q, and 3 times r is 3r. And then on the other side, I have parentheses also, so I'm going to remove them by distributing. So I get 20q. And then I take 5 times the minus 7r, I get minus 35r. Now once I've removed the parentheses, now I want to combine like terms. So anything that has the same letter, so if I look right here, I have a q and a q, same letter with the same exponent, I can add the numbers. So 20 plus 6 is 26q. And I also have r, a 3r, and a negative 35r. So if I combine them, I get a negative 32r. And we want to have our expression in alphabetical order. Q comes before R, that's why I did that first. And so there's our simplified expression. Let's look at this next problem where I'm going to distribute. So I get 12x minus 6y. And then that's a negative 2 right here that I'm distributing. So I'm going to get a minus 6x, and then I'm going to get a minus 2y. If you forget that minus sign right there and just see that as a 2, you're going to make a mistake in your distribution. So make sure you distribute the negative with it. Now I can combine like terms. I have a 12x and I have a negative 6x. When I add them up, I get 6x. And negative 6y and a negative 2y gives me a negative 8y. Once again, I'm in alphabetical order, so I've simplified my expressions.